G'day team, welcome back to another video. So today we're going to be moving on in our polynomial work to solving cubic equations. So this is following in the Hazy 11 Methods textbook and it's chapter 4D. So a cubic equation is an equation of the form ax cubed plus bx squared plus cx plus d which equals 0, where a, b, c, d are constants and a cannot equal 0. If a is equal to 0, then we actually only have a quadratic. So we can solve cubic equations in two ways. We can solve them algebraically if we are given one solution, or we can use technology. Using technology means having a graphics calculator and using the equation solver function on your graphics calculator. Today we're going to be focusing on how to solve it algebraically. So we're going to run through a couple of examples together. So questions will often be set out like this. X equals 2 is a solution, okay, so it gives you a solution of the polynomial, so 2x cubed, take 9x squared, take 2x plus 24 equals 0, and it will ask you to find the remaining solutions, all right? So like we did in chapter 4C, we're going to be using that same kind of strategy for equating coefficients. So first of all, we take the given solution and turn that into a linear factor. So we know a 0, if x equals 2, then that comes from the linear factor x take away 2, okay? So that's our linear factor. We write out our polynomial on the left-hand side, so 2x cubed, take 9x squared, take 2x plus 24, equals that linear factor. Now, in the previous chapter, we would have a and c here. There is actually a way we could find that. So the way we do find that is we look at the term for x cubed in the original polynomial, divide that by x. So divide this first term by x, and that will give us this here. So we actually need a 2 in here, okay? And we can check that by expanding back out. X multiplied by 2x squared is 2x cubed. Now we can also do that with our constant term. So again, looking at the constant term in our polynomial, dividing it by this term here, so negative 2, negative 24 divided by negative 2 is negative 12, okay? So we've just kind of eliminated having to find 2 extra unknowns. So just like we did before, we're going to expand this out. We need a little equal sign here. So x times 2x squared is 2x cubed. Then we've got x times bx, which is bx squared. Take x times negative 12, negative 12x. Take 4x squared, take 2bx plus 24, okay? Now we write our original polynomial back down here on the left-hand side. On the right-hand side, we're going to take out a factor of x squared from these two terms here, writing our coefficient at the front. And then we're also going to do the same with our x term, so taking that x as a common factor out and writing our coefficients. Now we're at the point where we can equate those coefficients. So we only need to look at the x squared and the x terms because they're the only ones with unknowns. So the x squared term, b take 4, so the coefficient of x squared on the right has to equal the coefficient of x squared on the left, so negative 9. Adding plus 4, so adding 4 to both sides, b is equal to negative 5. Now, we found b, but it's also always good to do a little check. So we're going to use equating coefficients on the x term just to check that b is negative 5. On the left-hand side, the coefficient for x is negative 2. On the right-hand side, it is negative 12 take 2b. So negative 12 take 2b equals negative 2. We're going to add 12 to both sides, so negative 2b equals 10. Therefore, b equals negative 5. So that's our little check. We then insert or substitute our b value into our quadratic. So our original polynomial equals x take away 2 times by 2x squared, take 5x, take 12. Okay, so all we need to do now is factorize that quadratic. So that comes out to be x take 2 times by 2x plus 3 times by x take away 4. All right, so therefore our solutions are x equals 2, x equals negative 3 on 2, and x equals 4 if we're solving these three linear factors. And that is the question done. So another example, all right. So negative 3 on 2 is a solution to 2x cubed plus 3x squared, take 8x, take 12. So we should be writing x equals, all right, finding the remaining solutions. So when we've got a solution that's a fraction, it is a bit harder to find that linear factor, but we have actually just done it up here. So negative 3 on 2 comes from the linear factor 2x plus 3. A good way to look at it is the denominator will become the coefficient of x, and then you flip the sign of the numerator, and that's your second term. So exactly the same process as before, writing out the polynomial, writing out our linear factor. Using that same trick as before, 2x cubed divided by 2x gives us x squared, so we've got our a coefficient of 1. And then again, negative 12 divided by 3, that's negative 4. So we've got our constant term as well. Again, we would only have to find b now. Expanding that out like we did above, collecting our coefficients here, all right, and then we're going to equate our coefficients. So for x squared, 3 has to equal 2b plus 3. So you'll find that 2b equals 0, therefore b equals 0. And we can do a check with the x term. So negative 8 has to equal b, take 8. Add 8 to both sides, and b equals 0 again. So what we can do, we can then substitute that value into our quadratic up here, and we'll find that our polynomial 2x cubed, take 3x squared, take 8x, take 12, is equal to 2x plus 3, so the linear factor will given, multiplied by our quadratic x squared, take 4. Now, you might recognize this little pattern here, so we've actually got the difference of perfect squares. So when we factorize the difference of perfect squares, we have a take b, a plus b, all right? So we've got 2x plus 3 comes down, then we've got a take b times by a plus b, all right? So therefore, our solutions are x equals negative 3 on 2, 2, and negative 2, all right? So that's how we do that. Yeah, if you are happy with that and comfortable, please have a crack at some of the questions in 4D, and we'll see you guys next time.